everyone, this is section 6.4, day 9, talking about trigonomic identities. So we only have about 2 more days of notes, and the rest are going to be about identities and kind of working around with those and making right sides equal left sides. So the best thing I can suggest is try one way. If it doesn't work, be resilient and try another way. Okay, I'll explain what that means as we go, but it's a lot of effort needed on these last couple days. First off, here are some basic trigonomic identities. You are going to need these as we solve these problems, so you can do a little bit of substitution idea. From the first fact, there's 2 more identities that I want to mention. So we have sine squared plus cosine squared equals 1. With doing a little bit of algebra, we also can see you can get cosine squared theta equals 1 minus sine squared theta. That might come in handy if you need to maybe cancel out a cosine squared theta or replace it. You know you have this identity that it's equal to. Another one, using the same identity, is getting sine squared theta by itself. Maybe that's in your identity somewhere and you need to simplify, so that could be a substitution you could use. Please star these and learn these, love these. It's going to make your life much easier. So example 1, using the identities above. Suppose that B is an acute angle and cosine of B is 2/5. Find sine of B and tangent of B. First thing I like to do is always draw a picture. Notice the cosine is positive. So if I think about my little quadrants, all students take calculus, you know that the 2 quadrants that cosine is positive would be the first and the fourth. But because it says acute, that means it needs to be between 0 and positive 90 degrees. So that kind of narrows our search down a little bit, and we know it's only going to be then in the first quadrant. That's where our angle B is going to be. We know the cosine is 2/5. So cosine, remember, is adjacent. So this length would be 2 over hypotenuse. This length would be 5. Now, I want to find the sine of B using my identities. So I'm looking above at step 1, step 2, or not step, but identity 1, identity 2, identity 3, and I'm going to see if I can plug in somewhere to find the sine. So that's going to be my first step. So first one I'm going to do is try to find the sine of B. Well, using the sine of B given the cosine of B, I think I'm going to use that first one. And that seems like a very good identity to use. I'm going to do my sine squared theta, I don't know it, plus instead of writing cosine squared theta, I know that cosine theta is 2/5. Make sure you square it, and it equals 1. So I'm using the first identity there. I know the cosine, which is why I chose it, and I want to find the sine, which is another reason why I chose it. Now we're going to do some algebra. I'm going to get sine squared theta plus 4 over 25 equals 1. I'm going to go sine squared theta, subtract the 4 over 25 to the other side. Get 21 over 25. I don't want sine squared. Remember, I just want sine. Ooh, sorry guys, this whole time I should have been using B. That's the angle name. I'm sorry. Some of you were like, where did theta come from? Don't worry, it's just B. So we're going to square root both sides. And you'll get sine of B equals plus or minus square root 21. I actually can simplify a little, right? Square root of 21 over 5, because square root of 25 is just 5. And now the big question arises. Is it positive or is it negative? Well, heading back to our all students take calc idea, I'm in quadrant 1 here, so that means all are positive. So at the very, very end, the only sign of B is going to be positive, root 21 over 5. Okay. Pretty cool, right? Now the next one, I want to find tangent of B. Well, for tangent, let's look at our 3 identities from above. Notice the only one with tangent is number 2 and then a little part of number 3. So using our best judgment, I think I'm going to try number 2. So I'm going to use number 2 identity. I want to find the tangent of B. And look at, I actually know the sine and the cosine already. How great is that? So tangent of B is going to equal the sine of B over the cosine of B. Well, I know from my first part that sine of B is root 21 over 5. And the cosine, which was given in the problem, is 2 over 5. Now some of you are like, oh no, Ms. Ferks hates having fractions in a fraction. Well, yes, I do. So simplifying, instead of dividing by a fraction, you can multiply by the reciprocal. Doing so helps you cancel out those 5s. And you're left with then the tangent of B equaling root 21 over 2. Okay. So hopefully it's not too bad. Pretty much treat those 3 highlighted as puzzles. Use them as you need to solve for the given trig functions. Let's try a couple more to see if you got the hang of this. So we're going to use identities to calculate the trigonomic functions again. We're given that sine of theta is 2/3. And the angle theta is between 90 and 180. So originally I would draw my all students take calc. Since sine is positive, I would think it would be in quadrant 1 and 2. Both of those have positive signs. But it adds this little part. It needs to be between 0 and 180. So that means the only quadrant it can be in, is quadrant 2. So please use all those facts, draw your picture, because in the end we have to figure out if the trig function is positive or negative. Okay, so the sine is 2/3. So sine is opposite over hypotenuse. And I want to find the cosine and the tangent. Okay, so I have those 3 identities from above in my noggin. I'm actually going to use the first identity again. The idea of sine squared theta plus cosine squared theta equals 1. The reason why I'm choosing that is because I'm given the sine, which is 2/3. Make sure you square it. And I'm solving for the cosine. That is the puzzle that makes the most sense to use. Doing some algebra, I get this is 4/9. I'm going to subtract it to the other side and get 5/9. I don't want cosine squared, so I'm going to square root both sides. So the cosine of theta is plus or minus root 5 over 3, because the square root of 5 is square root of 5. Square root of 9 is 3. Now the question comes into play. Is the cosine positive or negative? Well, look at our quadrants. We're in quadrant 2. Quadrant 2 says only sine is positive. That means cosine is negative. Make sure you make that, should be 3. That distinction. It's not going to be plus or minus. It might not always be positive. It might not always be negative. That's why you use your all students take calc. Now we're going to find the tangent. Just like above, I'm going to use the second identity again because that one involves the tangent and the sine and the cosine. So remember, sine is on top over the cosine. Let's plug in what I know. Sine is given as 2/3. Cosine we found at the beginning is -√5/3. You cannot have two fractions, so instead you're going to multiply by the reciprocal. Really nice because these are going to cancel. You're left with 2 over -√5. And another bell should be ringing in your head. You can't leave a square root in the bottom. We have to rationalize that denominator, which means multiply the numerator and denominator by that square root, giving us 2√5 over -5. So in the end, the tangent of theta equals -2√5 over 5. And let's take a quick second and actually confirm that negative sign. We are in quadrant 2. That's where my angle is based on the sign being positive and being between 90 and 180. So only the sign should be positive. Good. We got tangent to be negative. That means we're good to go. Okay. This is a partner/lone wolf try. Hinting, don't forget to rationalize the denominator. So I'm going to get you started, and then I'm going to set you free to either meet with a partner or try it on your own and see if we can get a little extra points when we come back to class. So, suppose that the cosine of theta is t over 2, where 270 degrees is less than theta and less than 360 degrees. So that's telling us we have to be in this quadrant number 4 between 270 and 360. I know cosine is t over 2. So here's my angle. Cosine is adjacent over hypotenuse. And we want to express the 5 other trig values. So the past 2 examples, we've just done cosine and tangent. So that should be easy. You should be able to do the cosine and the tangent from above. And you're like, well, that's just 2. Exactly. The next 3 are going to be the secant of theta, the cosecant of theta, and the cotangent of theta. Okay. Quick reminder, the secant, cosecant, and cotangent are the reciprocal of the 3 basic trig functions. So once you're able to find the cosine and tangent, and you're given the cosine here, you just have to do the reciprocal on the last 3. I'm going to tell you, you will have to rationalize the denominator. You will have to verify using the all students take calc about which will be positive in this 4th quadrant down here. Hintity, hint, hint. And then we're going to go over this in class. So please give it a try and we'll go over it when I see you next. Have fun, my dears!